So this is the crawl space part 2. You can see I've brought my pen type moisture meter down. And a couple of things before we get to that. In terms of building assessment. So this froth pack foam, question is, does it need an ignition barrier? Because the code says that the surface of spray foam in any space, even crawl spaces, has to be protected by ignition barrier, which is, I think the doesn't develop smoke or flame for 15 minutes. It turns out that the newer froth pack, I don't know exactly when it switched, but that foam is included with ignition barrier, so you technically do not have to add a separate ignition barrier to the surface of a froth pack foam. The other thing is, you're maybe looking up and saying, what the heck is that insulation, the ridge insulation between the floor joists? That's leftover insulation from a prior attempt to insulate the floor before the crawl space was moved from a vented crawl space. I used some of those pieces to work on the ridge insulation around the perimeter, but it's basically just leftover. And so when you do building assessments, it's important to collect whatever information you can from the building owner, because quite often the history, odd things will be explained because you're looking at a snapshot of the building, but they have some sort of longitudinal information about what has happened to the building over time. And I did mention that the source of moisture in this crawl space has been a bit of a mystery for me, because I've worked pretty hard to eliminate sources of moisture, and yet this space runs high and it needs to be dehumidified at times when the full basement does not. So I think part of it is that these interior walls that don't have the froth pack is definitely a vapor retarder, class 2 vapor retarder for moisture that's in the block. But these other two walls are not covered, and I think that's where the moisture is coming from. But I have not completely figured that out. Okay, so what I wanted to show you in the crawl space was, if I'm running about, say, 68% relative humidity and around 74 degrees in this crawl space, you can take those two numbers, go to the equivalent moisture content, and if the air mass in here has been steady for a very long time, the wood takes on moisture from the air and gives it off, but it takes time. It takes at least 3 weeks. So if the relative humidity and temperature inside this crawl space is stable, then the floor joist should reflect that content. And if they don't, you know there's a source of moisture besides what's just in the air. So I'm going to take the pins and drive them in the 1/2 inch here in the middle of the room, and you can see that the moisture content is 13.2%. Okay, green light's on. And so what I would do is take the numbers that I just read to you, the 68% relative humidity and somewhere between 72 and 74 degrees, go to the table and see how 13.2 compares to that. And I think what you're going to find is that this 13.2% moisture content by weight does reflect that in the middle of the room, the only source of moisture is the moisture in the air. But now what I'm going to do is go over to where the floor joists are let into the concrete block, right? So I'm going to drive the pins in here and do a moisture content reading, and I'm at 15.3. So what that suggests is that indeed the floor joist ends are seeing more moisture than just from the air. All right, so and I'm not even really completely against there, because the let-in floor joist ends that are actually contacting the concrete block are probably another 3 or so 4 inches in that direction. But what I'm going to do is, you always take more than one reading. I'm going to move over here and do the same thing and see what we get. 14.3 is the reading there. Okay. And then I'm going to come over to here and do one more in this corner. And again, I'm looking for the relationship between the moisture content of the wood that's right in the middle of the room, because it just should reflect the moisture content in the air, and compare it to what would be the moisture content, and you can see it's 14.6. So what does all this mean? Well, first of all, you can look at this, the visual inspection is where we always start. And I don't know if I mentioned this in the other part on the crawl space, but if you look at these floor joists, there's no mold, there's no mildew, there's no worn or staining that we can see at the ends. And so even at a steady moisture content in the summer of, say, 68, even up to 72% relative humidity, and we start to see mold and mildews around 70% generally, but that's not happening down in this basement. So yes, the lead-in floor joists may be a little bit wetter, but they're within an easy range. Like, we don't start really worrying until 19 to 21% moisture content by weight, because then we will start to see mold and mildew. So is it elevated a bit? Yes. Is it a problem? No. And another tool we can use is, I always carry a pocket knife with me with a lock blade, and this is, the first way besides the simplest test is is it punky, or are you getting a good solid sound? And so even before I start taking moisture measurements, I'm testing and looking for what the condition of the wood is by using the tip of my knife. So we use all the tools we have together to try to establish what the pattern is in terms of how this crawl space or any space is performing over time. And I would say that even though that ventilation system is a bit of a kludge, it has been working to help keep the moisture content of this space in a range that makes the crawl space successful.